All right, hello everyone. Okay, so this is our third example. So let's try to solve this linear system of equations and then see what we can get. Okay, so first of all, I'm going to write the augmented matrix. So the coefficients of in the first equation are 1, 1, negative 2, and the right hand side is 1. And in the second equation, there's no x on. So here 0, 1, negative 1, 3. And then in the third row we have negative 1, 4, negative 3 and 14 in the right hand side. So here we go, we have the augmented matrix. Now let's do the row operations. Now our first goal is to create that triangle of zeros right under the diagonal. So here we have the triangle. So our leading entry in the first row is that 1, okay, and under that everything else should be 0, right? So we should have 0 here and we should have 0 here. So we already have 0 in the second row, first position. All what we need to do is to make 0 on the third row, first position, right? So third row, first column. So the way that I'm going to do is simply add the first row to the third row, right? 1 plus negative 1 is 0. So first row doesn't change. 1, 1, negative 2, 1, 0, 1, negative 1, 3, 0, 1 plus 4 is 5, negative 2 plus negative 3 is negative 5, 1 plus 14 is 15. Okay, that's easy. Right, now then the next thing to do is, let's see. So we are done with the first column. We have the two zeros under the leading entry. We move into the second leading entry. So the second leading entry is onto the right of should be onto the right of the first leading entry, okay, previous leading entry, and that's the case here. So here we have the first leading entry and the next leading entry is onto the right of the previous one. Good. And it's non-zero. Good. So all what we need to do is make 0 in the entry in that column under the leading entry. So 5 should be 0. To make 5 0, what we can do is we can multiply the second row by negative 5. And then this one become negative 5. Negative 5 plus, when you add it to the third row, negative 5 plus 5 is 0. So 1, 1, negative 2, negative 2, 1, and 0, 1, negative 1, 3. So 0, 0. So negative 1, if you multiply it by negative 5, it's going to be 5. 5 plus negative 5 is 0. Okay, so it seems like now we are again running into a situation that we saw in the previous video, right? We have everything 0 just before the point where we separate the right hand side. Okay, so we'll see. So 3 times negative 5 is negative 15. So negative 15 plus 15 is 0. Okay, right. So we have the triangle of zeros we want. Okay, but again the problem is in the third row, okay, there's no leading entry. Leading entry means the first non-zero number in the row, and there's no non-zero number, so there's no leading entry in this third row. So the entire row is 0. This is very different from what we saw in the previous video's example. In the previous video, if I remember correctly, we had 0, 0, 0 and then 22. Okay, what this meant is 0 equal to 22, and that's a big no. That doesn't make sense. So we said in the previous video example, there was no solution. But here what we have is, if we write here, now we have the row echelon form, okay. We don't need to worry about the reduced row echelon form, okay. Here I'm going to try to find the solution from the row echelon form. So I'm going to write the equations. So from the first row, I'm going to get x1 plus x2 minus 2x3 is equal to 1, and from the second equation x2 minus x3 is equal to 0, equal to 3. And then from the third row, what I'm getting is, here the coefficients are 0, so 0 times all the variables is 0 on the left hand side, and the right hand side is 0. 0 equal to 0. Now, is 0 equal to 0? Of course, yes. Is this a contradiction? No, this is something that we know and true. Okay, it's not like a contradiction like we saw in the previous video. Okay, in the previous video it was 0 equal to 22, and that's a contradiction. That's wrong, but here it's correct. So this is the case where, you know, we cannot find what x3, right? Because this third row supposed to help us to find what's x3, and it doesn't help us to find x3. Okay, so we are gonna say that here x3 is a free variable. Free variable. So what does it mean by a free variable? Free variable means you can choose any value for x3. You have the freedom to choose the solution for x3. Now think about this. If you choose a number for x3, if you say that x3 is 10, okay, then you can substitute 10 here and find x2, and then from using that x2 and x3 you can find x1. And if someone else want x3 to be 100, they can also find a solution that's related to x3 is equal to 100. So this is the case where we have infinitely many solutions, because there are infinitely many solutions for x3. You can choose any number you like for x3, and that's why we call it a free variable. Okay, and in this case we call x1 and x2, then we call them basic variables. Okay, so this is an example where you have infinitely many solutions for a linear system of equations. And how can we identify such a system through row operations? Well, if you have a row that's entirely zero, everything is zero, including what's on the right hand side, then that means that variable, the variable corresponding to that row, is actually a free variable. Okay, and the system has infinitely many solutions because you can choose any number you like for that variable. Okay, now this is very different from the no solution case. You have to understand that. Okay, if you have a row where you have everything zero until the point that separates the right hand side, and if you have a non-zero number that represents the right hand side in that row, that's a no solution case. No solution case. Okay, b not equal to 0. That's where we get a contradiction. But if everything including that right hand side term is 0, that means if b is equal to 0, that means infinitely many solutions. Okay, so that's how we identify such a case. Okay, so now with these 3 videos you saw 3 examples with 3 types of solutions: a unique solution, no solutions, and infinitely many solutions case. Okay, right, so right now what we have to do then is to do more problems and see these type of cases at least one more time. Okay, all right, so in the next video I'll do example solving. In the next video I'll solve many examples. Okay, all right, I'll see you in the next video.